In the last video, we made a HTTP request in JavaScript and then initiated an Elm app with the payload of that request. We learned how to use Elm decoders to turn that JSON into a robust data structure that we could use in our app. In this video, we're going to make that HTTP request with Elm itself. We're going to learn about error handling, loading states, and how to use that Elm decoder from the last video. Let's check it out. First up, let's actually build our program and see where we left off. From the console, I'm just going to pm parcel index.html. Looks like something's going on at localhost 1234. Check that in the browser. And we can see our bill swap rates showing up here, everything working really nicely. If we take a look at our index.ts file, we can see exactly what's going on here. We have this fetch request getting the data, and then we get this JSON and we initialize our Elm app. Inside of our app, we can see the init function, which is here. We're getting that value from the JavaScript, and it's then decoding that JSON with this decoder here. This pretty much matches the shape of the JSON we get back from the API. Once we have that data structure and we check that it doesn't have any errors, we set it as the working model that our app can use to display stuff. Easy peasy, nothing too complicated. What we want to do though is remove this JavaScript fetch request and actually do the request inside of our Elm app. And that's what we're going to do right now. Okay, if we head on over to Elm packages, we can see under popular packages here that Elm does have a package to make HTTP requests. If we check out the docs, we can see that we have all the usual suspects here to make up HTTP requests. And one that we're interested in is up here, and it's the get. So the way to do this is let's install this package from the command line, and in our project root, let's run elm install elm HTTP. We want to say yes to that. Awesome, that's installed. Now let's jump back into the project and we can import HTTP up here. Awesome, that looks good to go. If we expose get here and we jump to definition, we can see that it returns a command message. The only places we can really produce this particular command message is in the init or the update. The reason is if we check them out, we can see that init can create command messages and so can update down here. At the moment, we're not producing any messages, so that's why our update is empty, but that's all about to change. Okay, so the first thing we can do is set up our command. Let's create a function up here called getData. And this will return a command message. In the body, we can use get, the URL, and the URL, we can get that from the index.ts. We'll just copy that, chuck it in there, and then expect. We're going to use HTTP expect JSON because we are expecting a JSON value. We're going to add a message here called got data. Now, this doesn't quite exist yet, but you're going to see how we use this in a second. And then we're going to use the decode. Now, we're getting a complaint here because we don't actually have a message name got data, and rightly so. What Elm is asking for is a message to dispatch once we've tried to decode the JSON payload. Let's add that to our messages, and this is going to take a result, HTTP error, and also the data object. Now, where I'm getting this from is from the return type of expect JSON. If we jump to definition, we can see that it takes a message that can handle results of error and an A. And what's an A? Well, we can see that it's the result of decoder A, which for us is a type called data, which you'll see up here. Right there, JSON decoder data. Now let's go ahead and remove the fetch request as we're not going to be needing it. We can remove all this, and all we want left is that main.init. Yeah, and we'll just pass back an empty object for the flags. That looks good from here. Now let's go to our init and remove any flag handling we're doing. Now we do have a situation here because our model can be in either of two states, ready with the decoded data and error in case decoding fails. We haven't even made the request for the data, so we can't really use ready, and we haven't technically got an error either because again, we haven't made the HTTP request. So it seems we need more messages to capture the true state of our program. For now, what we're going to use is the error state because it's easy, but we're going to come back to this and make this much, much better. The other thing we can do is create a command, and this is where we're going to use our getData command. Okay, so if we add get data, looks like everything's compiling. Let's check the browser and see what's going on. Okay, so it looks like we're getting this error state, and that makes sense because there's nowhere in our code are we actually changing to another state. And we can also see that if we open the dev tools that we're in fact making a request and the payload looks like the data we're expecting. Okay, so back in the code, we want to head to our update function because updates where all our commands in an Elm program go to be handled. We can create a case on the message here, and the first message we're going to handle is the got data message. This message takes a result, and we will need to unpack and see what kind of response we get from our HTTP response. So we can do a case on the result, and the two variants of result are OK and error. Let's unpack error, and this will give us a HTTP error. So in response to error, we can simply set our model to error. And the string we'll give it for now can be something bad happened. We'll come back to this and make this better in a second. Let's now respond to our OK, and this will give us a data. And then what we want to do is set our ready model. We'll use ready, and this is capital R ready. Pass it the data, and that's our OK done. Yep, that works. Save that. Let's check out the browser, refresh this, and see what's going on here. Okay, doesn't seem like that's working. Let's just hard refresh. Nothing. Okay, so something's going on here with the decoder. Let's print out that error. And I'll just add a debug log. Error. And then pass it the error. And this needs to be a variable, so let's put an equals here. Cool. Let's check this out now. Go to the console, and we can see that looks like it's not got a field date as of. If we check the network, see what's coming back. Yeah, okay, we can see that that field's not actually showing up, and that's why the decoder's erroring. And I think the reason this is happening is because we've ticked over to the weekend and there are no bank swaps, and it looks like that API returns something different when there's no swaps instead of like an empty list. So that's a bummer for us. I'll be back on Monday to finish this off. And boom, everything is working perfectly. We have our swap rates showing up. Nice stuff. Now, one bit that's really annoying though is the program starts off with an error state, which is absolutely not what we want. We want to give the program a better state to start with that actually reflects what's going on. So let's sort that out now. Now, to achieve this, what we can do is look at this model type here, and we can add an extra variant to this, and we're going to call it loading, right? This is going to handle our loading state. Now, the view is going to complain about this. So let's go down to the view, and what are we going to render for this loading state? So let's put an extra case here. This is going to be loading. And very simply, I'm just going to add a H2, nothing too fancy. And the text of that H2 is going to be loading. Cool, check that out. And nothing's happening because we need to actually set this up in the update. So if we head on back, and I meant the init, not the update. In the init, we can actually initialize the program with the loading state. So here, we'll put on loading, save that, and we get our bank swaps showing up, loading state, very nicely done. And that's HTTP requests. Okay, so in this video, we learned how to make HTTP GET requests from within our Elm program and also handle the request lifecycle to show some loading state whilst that request was in flight. Making HTTP requests and handling responses in Elm is a really big deal, and it unlocks a whole lot of power for your programs. In the next video, I'm going to be talking about how we do CSS styling from within Elm. Thanks.